Okay, so good evening everyone. Welcome back to part 2 of dual nature of radiation and matter. Today we'll be completing the chapter. Yesterday we have completed, let's say, almost one half of the chapter. Today we will complete the remainder of the chapter. Um so we have completed Einstein's postulates as well, quantization, right? So now we move on to wave particle duality, right? Wave particle duality of electromagnetic radiation.
Wave particle duality.
Yes. So here, as we have completed yesterday, the summary and analysis observation experiments, yes, that table has been deleted. It is into a deleted portion. तो अभी बचता है अपने पास ये 14.3 का point, that is wave particle duality. Okay. And उसके बाद 14 point I guess 5 and 14.7. So this is all that we have. Okay, चलिए, let's start and finish this chapter as quickly as possible. Yes. Okay, so now the remainder part is very small and very easy. Okay, I mean, you can say it's just half an hour or 45 minutes. That's all that we have. Okay, so now wave particle duality of electromagnetic radiation. In here, you must have seen light coming through a slit. Okay, so this is a very common observation that we do in school, right? स्कूल में जब बैठ के बोर होता है कोई लेक्चर में, तो वी आर लाइक लुकिंग आउट ऑफ द विंडो एंड द सन रेज आर काइंड ऑफ पीपिंग इनसाइड, ओके, थ्रू द विंडो. ठीक है, उधर से अंदर अपने स्कूल में क्लासरूम में गिरते रहते हैं. एंड इन दोज वेव्स यू कैन feel or see the waves, or what do you say, the rays of light that are coming. Okay, so from that we can understand that light is acting in a wave nature, right? Light is acting in a wave nature. मतलब we have done examples in the third chapter, kinetic theory of gases and radiation. इसमें हमने देखा था about diffraction, interference. Okay, तो ये सारी चीजें हम ऑलरेडी देख चुके हैं. ठीक है, तो as we know, compression, rarefaction, polarization, then diffraction, interference, all these phenomena or all these properties shown by the light are in the form of waves. Okay, are in the form of waves. ये आप याद रखिए, आप समझिए, क्योंकि जो लाइट सन से आ रहा है और ये सारे एक्सपेरिमेंट्स भी जो हमने देखा है, this property of diffraction, interference and all that has been depicted or has been coming in the form of waves. Okay, has been coming in the form of waves. And so this proves, and this is a very common observation, right? This is a very common observation that we regularly see in day-to-day life. Okay, and this is what is wave nature. So wave nature has been confirmed very early as well, मतलब as early as possible. Okay, तो वो बहुत पहले पता चल चुका था साइंटिस्ट को. But then later on, scientists also said that light जो है it also acts in particle nature as well. ठीक है, wave particle duality. Duality is two or multiple, right? And wave and particle are the dual things. Wave and particle are the dual things. So wave and particle में हमने wave nature तो देखा, right? We have already seen in various experiments and our day-to-day life about the wave quality, the wave theory of light. बट तो आपको वहां पे सिंगल स्लिट एक्सपेरिमेंट हो गया, डबल स्लिट एक्सपेरिमेंट हो गया, ये हमने कर चुके हैं. ठीक है, तो इन नाउ कंसिडरिंग द पार्टिकल नेचर ऑफ द लाइट, राइट, पार्टिकल नेचर ऑफ द लाइट। तो फोटो इलेक्ट्रिक इफेक्ट में हमने पार्टिकल नेचर देखा है, राइट, द लाइट पार्टिकल्स हिटिंग द metallic surface and metallic surface emitting electrons. Okay, so this is what was happening. Okay, so that is one example. Also we have seen another example which is Ferris black body radiation. ठीक है, काइनेटिक थियरी ऑफ गैसेस में एंड रेडिएशन में हमने ये एक्सपेरिमेंट किया था, ये हमने एक्सपेरिमेंट पढ़ा था about black bodies absorption and radiation. Okay, about black bodies absorption and radiation. तो वहां पे हमने क्या देखा था, that there is a very perfectly black body, Ferri's perfectly black body, and that body absorbs all the energy that has been inferred or incident upon it. तो वो जो और and there's a very small slit through which light is allowed to pass in. Okay, well, through which light is allowed to pass in. तो वो जो small slit जो है वो small slit and the absorption of all the light particles explains us or helps us understand that light also behaves in particle nature, right? अगर वो particle nature नहीं होता तो वो जो black body है उसको absorb नहीं कर पाते, तो only wave होता तो the wave would have moved ahead and moved on or maybe passed through it, but no, the Ferri's black body does not allow it. Let's take example of black holes. ठीक है, ब्लैक होल्स का भी किस्सा वही है, दे आर ईटिंग एवरीथिंग, ठीक है, दे आर ईटिंग एवरीथिंग एंड वो खाते हैं, मतलब ब्लैक होल सब कुछ खा जाते हैं, व्हाटएवर दैट कम्स इन देयर वे, दैट मींस दे आर ईटिंग अप द पार्टिकल्स दैट देयर आर अराउंड। ओके, सिमिलरली वो लाइट को भी खा जाता है, तो लाइट को भी वो ब्लैक होल खा जाता है या आपकी फेरिस ब्लैक बॉडी खा जाती है। दैट डज मेक अस अंडरस्टैंड दैट लाइट इज एक्टिंग इन a particle form or in particle nature. Okay, and this is very important. तो ये तीन चार examples है which helps us understand particle nature, and few experiments that we have already done like single slit experiment, double slit experiment, which have helped, or polarization, refraction, rarefaction. Okay, तो ये सारे हमको क्या समझाते हैं, हमको ये सारी चीजें डायफ्रैक्शन, इंटरफेरेंस, ये प्रॉपर्टीज समझाती है, and we learn the wave nature of the body, oh sorry, waves, light waves. Okay, hello Gunjan, how are you, good to see you. And नहीं, आज कोई नहीं है, the reason being the channels have been split, so there's a misplacement of lectures, you can say. A lot of students are still unaware of this new channel, and yeah, तो उस वजह से थोड़ा सा अटेंडेंस आपको कम दिखता है। ओके, चलिए, नाउ विल मूव ऑन टू दिस चैप्टर। ओके, ये जो अभी पार्ट दिया है, वेव पार्टिकल डुअलिटी ऑफ इलेक्ट्रोमैग्नेटिक रेडिएशन। ओके,
of electromagnetic radiation. In its interaction with matter, light behaves as if it is made up of packets of energy called quanta.
quanta, this has already
Later,
been told
it was
to us.
confirmed from other theoretical and experimental investigations that these light quanta can have associated momentum. Hence, the question comes up whether a particle can be associated with the light or electromagnetic radiation in general. Particle nature was confirmed by Compton in 1924 in experiment on scattering of.
So this guy was the one who helped us understand the particle nature of light, right? कि particle होता है, light is acting, is working in a particle format, और उन्होंने 1924 में कॉम्पटन्स एक्सपेरिमेंट आप या कॉम्पटन्स इफेक्ट जिसको बोलते हैं, वो इफेक्ट अपने को एक्सप्लेन करता है द पार्टिकल नेचर ऑफ द काय म्हणतो त्याला आपण लाइट, सॉरी, इलेक्ट्रोमॅग्नेटिक रेडिएशन म्हणणार तो लाइट. ओके, इलेक्ट्रोमॅग्नेटिक रेडिएशन भी आप बोल सकते हो.
X-rays due to electrons of matter. Summary of these results is given in the box below, and you can know more about these experiments from the reference books given at the end of this book or from the link given below.
Okay, so basically this is not what is going to come in exam. So हमको इसके ऊपर मेहनत या ये पढ़ाई करने की जरूरत नहीं है. What is Compton effect and how Compton effect works and all, The board has given you, the textbook has given you some links or reference books through which you can refer, but absolutely not necessary क्योंकि वो पूछने नहीं वाले. You just have to remember Compton effect. ठीक है, you just have to remember Compton effect क्या है, Compton effect कहाँ पे लिखना है, इतना अगर आपको याद रह गया तो that would be sufficient for you to get marks. That's it. Okay. तो आप मत पढ़िएगा, ठीक है. डोंट गो एंड click these links and read those reference books for your more understanding की फिलहाल हमको बोर्ड एग्जाम्स के लिए कोई जरूरत नहीं है. ओके. So Compton effect अपने को खाली particle nature of light, and it was scientist Compton in 1924 who helped us understand the wave nature by doing some experiments. Sorry, particle nature by doing some experiments.
Compton showed that photon has an associated momentum along with the energy it carries. All photons of electromagnetic radiation of a particular frequency have same energy and momentum. Photons are electrically neutral and are not deflected by the electric or magnetic field. Photons can have particle-like collision with other particles such as electron. In photon-particle collision, energy and momentum of the system are conserved but the number of photons is not conserved.
Okay, so photons. Now बात हो रही है photons की. Photons are electrically neutral. Okay, ना वो electrons की तरफ दौड़ते हैं ना वो protons की तरफ दौड़ते हैं. ठीक है, these are photons which are electrically neutral and they generally don't get attracted. Okay, but it is obvious that they might collide with electrons or protons which are around it. Okay, तो photons क्या है? Photons is the smallest part which okay, the smallest part which a light belongs to. Okay, तो ये जो photon है, this photon when collides with other particles, ठीक है, let's say a electron, let's say a proton, its energy will be conserved. ठीक है, उसका energy waste नहीं होगा, उसका energy disperse नहीं होगा, but the thing is the number of photons might increase or decrease. The number of photons might increase, मतलब वो एक जो photon particle है that might get divided into 2 or 3 particles, and if there are 2 photon particles who are colliding with each other, तो वो 2 photon particles might get converted into one single photon particle. Okay, तो ये चीज है, and this is what we have been explained.
Photons can be observed or new photons can be created.
Yes.
Photons can transfer their energy and momentum during collision with particles and disappear. When we turn on light, they are created.
See, these photons
Photon
are
always moves with the speed of light. It is never at rest.
right. So photons are always moving. You cannot find photons at rest. And this is what 3 into 10 raised to 8 meter per second. जो velocity है, this is the velocity with which these photon particles moves. Absolutely. देखो, अगर वो smallest particle of light है, ठीक है, if a photon is the smallest particle of light, तो obviously all these particles coming together will make light. राइट, तो लाइट का स्पीड तो अपने को मालूम है 3 into 10 raised to 8 मीटर पर सेकेंड. ओके, सो दैट डज मीन ऑब्वियसली कि आपके जो फोटॉन्स है, आपके जो पार्टिकल्स है, वो भी वही स्पीड से दौड़ते होंगे, तभी आपके स्पीड लाइट का भी स्पीड 3 into 10 raised to 8 मीटर पर सेकेंड है.
Mass of photon is not defined as we do for a particle in Newtonian mechanics. Its rest mass is zero in all frame of reference. Effects of wave nature of light were seen in experiment on interference or diffraction when the
right. So these experiment, double slit experiment, single slit experiment, we had already seen or we had already learned and experimented in our earlier.
Separation between two slits are smaller than or comparable to the wavelength of light. If the slit width is large or the spacing between the slit is more, the interference or diffraction pattern will not be same and the wave nature will not be so obvious.
Yes, obviously. तो ये जो placement है, the placement of these slits is very important, very crucial, and thickness of this slits as well as the length of the slits is very important, so as to get the perfect shadow region and the perfect illuminated region.
It was realized by scientists that some phenomena observed in experiments in the laboratory or in nature, like interference and diffraction, can be explained by considering light in particular and electromagnetic radiation in general as a wave. On the other hand, some other observations like photoelectric effect and blackbody radiation can be explained only if we consider electromagnetic radiation as consisting of photon.
Photon. See, now this is the photoelectric effect, right? This is photoelectric effect. उसका experimental setup है. Chapter के start में ही हमने देखा था. Okay, so this experiment has helped us understand that yes, light does travel in the form of particles. Light does travel in the form of particles, and this black body experiment also, these photons, the light particles क्या है? Photons. These photons are actually particles which are going to make some change.
With definite quantum of energy and momentum as evident for quantum scattering experiment. Also, there are some phenomena which can be explained by both the theories. It is therefore essential to consider that both the characteristics or behavior hold good. One dominates in some situation and the other works in rest of the situation.
Okay, so it's not necessary that both will always be together, yeah, both will always oppose each other. It's not like that. It's not like that. It is that sometimes the wave nature will be more dominant, right? For example, if you're doing some slit experiments, सिंगल स्लिट डबल स्लिट जो भी है, या फिर रेयरफैक्शन है, पोलराइजेशन है, तो ये सारे एक्सपेरिमेंट्स अगर हो रहे होंगे तो लाइट विल बी मोर ऑफ वेव इन नेचर, डायफ्रैक्शन, इंटरफेरेंस, ठीक है, ये सब वेव नेचर में मिलेंगे आपको. But when you are doing these two experiments, the photoelectric effect, the Ferris black body experiment, the Compton effect, which is dealing with the momentum, right? So momentum बहुत important. One important thing is momentum. Momentum, frequency are very important, to show your wave nature as well. तो Compton effect है. तो ये तीनों जो experiments है have helped us understand the particle nature, जो यहाँ पे भी आपको दिया है. बस एक है कि कोई एक प्रॉपर्टी वेव नेचर कभी डोमिनेट करेगी, कभी कभी आपकी पार्टिकल नेचर डोमिनेट करेगी. डिपेंड्स अपॉन द सिचुएशन, डिपेंड्स अपॉन द एक्सपेरिमेंटल सेटअप.
It is necessary to keep both the physical models to explain the careful experimental observation. There is thus a need to hypothesize the dual characteristics of light. Later, it turned out that such a picture is required not only for light but for whole electromagnetic spectrum.
तो ये सिर्फ
This
विजिबल लाइट
phenomenon
नहीं,
is termed as wave-particle duality of electromagnetic radiation.
राइट? तो इलेक्ट्रोमैग्नेटिक रेडिएशन हमारे लिए सिर्फ विजिबल लाइट नहीं है. तो इलेक्ट्रोमैग्नेटिक रेडिएशन ये पूरा इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम के लिए अप्लाइड है. रेडियो वेव्स, माइक्रोवेव्स, इंफ्रारेड वेव्स, अल्ट्रावायलेट रेज, एक्स रेज, गामा रेज, इन सब के लिए अपना दोनों duality is applicable. Okay, that's it. This is all you have to do and write.
Do you know? The particle nature of radiation is seen in black body radiation and photoelectric effect. In the former, near room temperature, the radiation is mostly in the infrared region, while in the latter, it is in the visible and ultraviolet region of the spectrum. The third experiment, which established that a photon possesses
Compton
momentum like a
experiment है,
particle,
Compton's का
was
1924 का
Compton
experiment.
scattering, where X rays and gamma rays interact with matter. In 1923, A. H. Compton made a monochromatic beam of X rays of wavelength lambda incident on a graphite sheet and measured the intensity of the scattered rays in different directions as a function of wavelength. He found that although the incident beam consisted of a single wavelength lambda, the scattered intensity was maximum. This shift cannot be explained using wave photocell.
So this has been deleted. Not to worry about it. Okay. Photocell has been deleted.
ओके. हाय ब्रो, कैसा है तू?
मैं तो अच्छा हूँ. तू बता, तू कैसा है?
यार मैं तो ठीक हूँ. वैसे पढ़ाई कैसे चल रही है तेरी?
एकदम मस्त चल रही है.
क्या बात कर यार, मैं तो थक गया ढूंढते ढूंढते इंटरनेट पे. यूट्यूब पर भी देखा पर मैथ्स के सम्स के सारे सॉल्यूशंस कहीं पर भी नहीं मिल रहे. इवन मॉम हेल्प मी बट उनको भी नहीं मिला.
क्या बात कर रहा है? मेरा तो हो गया सब कुछ।
चल रे, पक्का मत मुझे कुछ भी। तूने पक्का डाइजेस्ट से कॉपी किया होगा। वो तो मैं भी कर सकता था, बट स्टेप समझना भी तो इम्पोर्टेंट है ना यार।
डाइजेस्ट? वो तो मैंने लिया ही नहीं है। पापा ने बस होम रिवाइज का पूरा सब्सक्रिप्शन ले लिया है। होम रिवाइज पे अलजेब्रा, ज्योमेट्री, इन सब के सारे सम्स के सारे सॉल्यूशन एक ही जगह पे होते हैं।
वाह यार, मतलब सब कुछ एक ही जगह मिल जाएगा।
और नहीं तो क्या। तू भी ये ऑनलाइन सर्चिंग छोड़, क्योंकि ऑनलाइन सर्चिंग में तुझे 2 या 3 ही सम्स मिलेंगे। लेकिन अगर तुझे तेरे सारे सम्स के एक्सप्लेनेशन चाहिए तो तू भी होम रिवाइज ले ले। बाकी होम रिवाइज सब संभाल लेगा।
होम रिवाइज, अब सर्चिंग बंद और लर्निंग शुरू।
ये है संजू की माँ और ये है राजू की माँ।
संजू, बहुत हो गया खेलना, अब थोड़ी पढ़ाई भी करो।
राजू, बस हो गई पढ़ाई, अब थोड़ा खेलने भी जाओ।
पता नहीं ये छाया राजू को कैसे पढ़ाती है कि वो पढ़ाई से हटने का नाम ही नहीं लेता।
अब बनाएं अपने बच्चे की पढ़ाई को उनकी गेम की तरह इंटरेस्टिंग होम रिवाइज के साथ, जिसमें टेक्स्ट बुक का हर सेंटेंस बच्चे लैपटॉप या टीवी पर एनिमेटेड मूवी की तरह देखकर एंजॉय कर सकते हैं। होम रिवाइज, जो बनाए हर सब्जेक्ट को इतना इंटरेस्टिंग कि आपको कहना पड़े।
बस हो गई पढ़ाई, अब थोड़ा खेलने भी जाओ।
होम रिवाइज, अब पढ़ाई हुई आसान।
Okay, welcome back. So photocell has been deleted. We move on to De Broglie's hypothesis. Use your brain power है बीच में.
De Broglie hypothesis. In 1920, use your brain power. Is solar cell a photocell? Answer: no, solar cell is not a photocell.
Solar cell is not a photocell, it is a photovoltaic cell, okay. Now we'll move on to De Broglie's experiment.
De Broglie hypothesis. In 1924,
So hypothesis क्या होता है? Hypothesis is without experimental setup. It's kind of with intuition, it's kind of with understanding. Okay, without experiment उन्होंने ये कुछ theories बताई है, ये कुछ assumptions किए हैं. Okay, without theory, because he has his knowledge but he does not have a proper experimental physical setup, and that's why he's not able to do, but he predicts, he proposes his theories on the basis of his understanding, okay, without a physical proof to it. So this is what is this experiment all about. De Broglie's, या आप इस De Broglie बोल सकते, pronounce as De Broglie. Reason being your this guy might be a नेदरलैंड का गाय, तो ये ब्रॉगली के जगह पे De Broglie ऐसा भी बोलते हैं.
Prince Louis de Broglie, pronounced as de Broglie, proposed on the basis of the symmetry existence in nature that if radiation has dual nature, sometimes wave nature dominates and sometimes particle nature, matter may.
So this was the guy जिसने सबके दिमाग में कीड़ा छोड़ दिया कि डुअल नेचर होता है. ठीक है, प्रूफ बीफ तो था नहीं बंदे के पास प्रूफ नहीं था, पर बंदे ने सबके दिमाग में कीड़ा छोड़ दिया कि नहीं, डुअल नेचर होता है, डुअल नेचर हो सकता है. अगर रेडिएशन डुअल नेचर में है, कभी वो पार्टिकल में है, कभी वो वेव फॉर्म में है, तो ये कंफर्म है कि वो बाकी सब जो भी है, बाकी सब भी. देखो, अगर रेडिएशन डुअल नेचर में हो सकता है ना, तो मैटर भी रेडिएशन डुअल नेचर में हो सकता है, ये उसने बोला. It's okay, Pratyusha. Good to see you today as well. It's great that you have already joined in by 5. Even this lecture might end by 5:30 or even before 5:30 because we have only 2 topics remaining. ठीक है, तो वो भी खत्म हो जाएगा झट से. उसमें भी इतना कुछ important है नहीं. This De Broglie's hypothesis, again being hypothesis, तो उसको पूछना थोड़ा मुश्किल है. Okay, they might or might not ask in the exam. ये चैप्टर में ये इतना पार्ट इंपॉर्टेंट है नहीं, बट स्टिल विल बी डूइंग. तो दिस वाज द गाय हु पुट अप अ थॉट इन एवरीबॉडीज माइंड दैट if light or radiation, light बोलो या radiation बोलो, if light or radiation are acting in particle as well as wave nature, ठीक है, लाइट और रेडिएशन जो भी है, जिसको भी बोलो आप, अगर वो दोनों या वो एक चीज पार्टिकल नेचर में भी एक्ट कर रही है और वेव नेचर में भी एक्ट कर रही है ना, तो जितना कोई मैटर है दुनिया में, मैटर ये बोलो या पार्टिकल बोलो, all these particles or matters will also be showing dual properties. ठीक है, मतलब हम जो है we as human beings, the chair and everything, ये सारी जो चीजें हैं, these also show some particle nature and some wave nature. अभी हमको तो अपना particle nature पता है, we are made up of atoms and molecules, right? We are made up of atoms and molecules. तो इस वजह से you can know or you know very well that we are a particle form in nature. ये तो पक्का है, particle form में है अपन. But when we talk about wave nature, तो कभी देखा है कि आपने जैसे इंसानों को कोई wave nature में? नहीं. We haven't seen ourselves into wave nature. तो वो हम 14.7 में पढ़ेंगे. पर ये जो कीड़ा है जो मैंने बोला, the thought for this concept was put up by de Broglie. ठीक है, ये उसने बोला और उस वजह से मैटर के लिए भी क्या बोलते हैं उसको, वेव नेचर हो सकता है. पार्टिकल के लिए भी वेव नेचर हो सकता है, हमारे जैसे फिजिकल बॉडी के लिए भी वेव नेचर अपना हो सकता है, जो हमको हम वेव फॉर्म में तो दिखते हैं नहीं, बट वो हो सकता है. ऐसा ये बोल के गया और पूरी दुनिया यही एक चीज के पीछे पड़ गई थी. Gamma speed is nearest to C. No. Okay, you are saying all the things that you have written, Pratyusha, are very correct. But those things that you have written already are not a part of this topic. Okay, this topic or this
may
concept.
also possess dual nature. Normally, we talk about matter as composed of particles, but are there situations where properties? This will become evident from the experiments on diffraction of electrons from the nickel crystals described later in this chapter. De Broglie used the properties frequency nu and wavelength lambda of a wave and proposed a relation to connect these with the particle properties. Energy E and momentum P. The momentum P carried by a photon of energy E is given by the relation P is equals to E upon C, which is valid for a massless particle traveling with a speed of light c, according to Einstein's special theory of relativity.
Obviously, the particle has to be very light. The particle has to be feather light or weightless to travel in the speed of light. तो वो ये particles के लिए applicable है. This hypothesis, this proposition by de Broglie is applicable to the particles who are very light in nature. Okay, very light in nature.
Using the Einstein's relation for E, P is equals to E upon C, which is equals to H nu upon C, which is equals to H upon lambda. Where lambda, the wavelength is given by lambda nu is equals to C. De Broglie proposed that a moving material particle of total energy E and momentum P has associated with it a wave.
Yes, Pratyusha, you are correct. आपको जो पता था आपने बोल दिया. That's good that you are speaking up whatever you know, and your knowledge certainly helps others as well who might be reading your comments as well. ठीक है, तो you are always giving good inputs. That's very good of you.
Wave analogous to a photon. He then suggested that the wave and particle properties of matter can also be described by a relation similar to equation 14.5 for a photon. Thus, the frequency and wavelength of a wave associated with a material particle of mass m moving with a velocity v are given as nu is equals to E upon h and lambda is equals to h upon p, which is equals to h upon mv.
ये v है.
He referred to these
This is
waves
v,
associated with the
Mass
material
into- sorry,
particles
mass into velocity,
as
yes.
matter waves. The wavelength of matter waves given by equation 14.6 is now known as the de Broglie wavelength.
This de Broglie's wavelength
Greater is the
उसको बोलते हैं.
momentum, shorter is the wavelength.
Yes.
Equation
तो जितना शॉर्ट वेवलेंथ उतना उसका मोमेंटम ज्यादा, जितना मोमेंटम कम उतना उसका वेवलेंथ बड़ा, और बड़ा वेवलेंथ होना बहुत ज्यादा जरूरी है, बड़ा वेवलेंथ होना बहुत ज्यादा जरूरी है फॉर अस, for humans to see that waveform in with bare eyes. Okay.
14.6 for the wavelength of matter waves is known as de Broglie relation. For a particle of mass m moving with a velocity v, the kinetic energy Ek is equals to half mv square. Lambda is equals to h upon mv, which is equals to h upon m into square root of m
These
upon
is
2
all
times Ek,
mathematical
which is
equations that
equals
we
to
have solved.
h upon square root of 2m.
तो ये सारा उसने बड़ा एक्सपेरिमेंटल मैथमेटिकल कैलकुलेशन करके किया है.
2 times
You don't have to
me
show
into
all this, right? From an exam point of view, for an exam perspective, this is not at all important. Okay, बहुत जगह पे तो ये पढ़ाते भी नहीं है, de Broglie's hypothesis बताया भी नहीं जाता है, but still we are going through it, but we can omit this part of his experiments and mathematical calculations. उसका कहना एक ही था, तो दिखाता है, but उसका particle nature भी होना चाहिए, and that is what has led to various experiments and then understandings of duality of all this nature of light and matter.
electron volt, which is equals to 6.63 into
So all
10 to
these
the power
calculations
minus
absolutely
34
not
joule
necessary.
second divided by square root of 2 into. Shortly after the existence of photon, particle associated with electromagnetic waves, was postulated, it was also experimentally found that electrons, subatomic and atomic particles like photons and neutrons also exhibit
Protons,
wave properties. The wavelength associated with an electron of energy few electron volt is of the order of few angstrom.
Few, ये देखो, ये जो
Therefore, to observe the wave
A
nature
naught
of
ऊपर लिखा है उसको
electron,
few
slit
बोलते हैं.
width or diffracting object should be of the same order of magnitude, that is of few angstrom. The wave property of electron was confirmed experimentally in 1927 by Davison and Germer in America and in 1928 by George P. Thomson in England by diffraction of electrons by atom in metals.
Okay, so wave property was already explained by these three scientists. In America, these two in America, and this guy in the England.
Knowing that the size of the atom and their spacing in crystal is of the order of few angstrom, they anticipated that if electrons are scattered by atoms in a crystal, the associated matter waves will interfere and will show diffraction effects. It turned out to be true in the experiments.
Yes, जो उन्होंने
Electrons
बोला
showed
उन्होंने experiment में
constructive
करके
and
दिखाया.
destructive interference. No electrons were found in the certain directions due to destructive interference, while in the other direction, maximum number of electrons were seen due to constructive interference.
So there is constructive interference and there is destructive interference. हमने waves में देखा था, wave optics ये chapter में हमने देखा था, and I guess we don't have to go through that chapter again for our more understanding. तो आप अगर वो chapter भी खोल के देख सकते हो, constructive interference and destructive interference क्या होता है, okay?
Louis de Broglie received the Nobel Prize in Physics in 1929, and Davison, Germer, and Thomas shared the Nobel Prize in Physics in 1937.
ठीक है, the
It
same.
was amazing that Sir J.J. Thomson discovered the existence of electron as a subatomic particle, while his son G.P. Thomas showed that electron behaves like a wave.
Right, so father-son जोड़ी जो थी, this father-son जोड़ी actually both of them winning Nobel Prizes in physics for some great discoveries and some great inventions. Okay, तो जे थॉमसन ने इलेक्ट्रॉन ढूंढा एंड उनके बेटे ने इलेक्ट्रॉन वेव फॉर्म में मूव होता है, वेव फॉर्म में उसका ट्रैवलिंग होता है, उसके बेटे ने या थॉमसन, जे थॉमसन के बेटे ने प्रूव किया. ओके, जे थॉमसन का तो नाम 5th-6th स्टैंडर्ड से हम पढ़ रहे.
Example 14.4.
Again, you have to use
An
the
electron is
formula from
accelerated
de
through a
Broglie's
potential
experiment,
of
which is
120
absolutely
volt.
not necessary. The reason being, अगर आपको एग्जाम्पल्स आने वाले हैं, अगर आपको मैथमेटिकल क्वेश्चंस आने वाले हैं, तो आपके पास और 15 चैप्टर पड़े हुए हैं. 15 में से भी मैग्नेटिक मटेरियल्स में कुछ है नहीं, तो यू हैव 14 चैप्टर्स रिमेनिंग, फ्रॉम विच they are more likely to ask questions than this chapter. Okay, तो इसका इतना जरूरी नहीं.
Find its de Broglie wavelength.
मैडम इलेक्ट्रॉन डिस्कवर किया था 8th में था शायद. आई गेस आई हैव रेड दिस इन 7th स्टैंडर्ड एज वेल. मे बी सम अदर बोर्ड, आईसीएसई बोर्ड में होगा या सीबीएसई बोर्ड में होगा. बट जे थॉमसन हैज बीन हर्ड एज अर्ली एज 7th स्टैंडर्ड और 6th स्टैंडर्ड एज वेल. क्योंकि बच्चों होमी बाबा अगर आप एग्जाम देते हो होमी बाबा वाला, तो आप 6th स्टैंडर्ड में भी आप पढ़ लेते हो. ठीक है, इवन इन 6th स्टैंडर्ड्स यू अंडरस्टैंड और नो who's J.J. Thomson and what had he discovered. That his discovery was electrons.
Solution. Given V is equals to 120 volt, we know that lambda is equals to 1.228 upon square root of V using equation 14.7. Therefore, lambda is equals to 1.228 divided by square root of 120, which is equals to 0.112 nanometer.
Nanometers. Done. इतना easy straightforward question है.
Use your brain power. Can you estimate the de Broglie wavelength of the Earth? Answer. De Broglie wavelength of any object is lambda is equals to h upon mv.
Momentum है,
But
h
v
Planck's
is
constant
equals
है.
to r omega and omega is equals to 2 pi upon t.
See, right?
Therefore, lambda is
So lambda is what? Your wavelength. H is what? Planck's constant. Yes, Pratyusha, I might have taught for some ICSE or CBSE students. ठीक है, तो h upon mv, ये mv is your momentum, this h is your Planck's constant, lambda is your wavelength. Okay, but v has been given by r omega. ठीक है, and omega is again given by 2 pi by t. तो ये सारे उन्होंने substitutions किए हैं in this equation.
v equals to h upon m into r into 2 pi by t, which is equals to ht upon mr into 2 pi. Now, average mass of the Earth is me is equals to 6 into 10 to the power 24 kg. R is the distance between the Earth and the Sun, which is equals to 1.5 into 10 to the power 9 meter. T is the time period of revolution, which is equals to 365 days. Therefore, T is equals to 365 into 24 into 60 into 60 seconds, which is equals to 3.154 into 10 to the power 7 seconds. Therefore, lambda is equals to 6.626 into 10 to the power minus 34 into 3.154 into 10. Therefore, lambda is equals to 3.6.
So this is the answer which shows de Broglie's wavelength of the Earth. This shows de Broglie's wavelength of the Earth. So you can see कितना छोटा wavelength है. 10 raised to minus 63 meters. 10 raised to minus 63 meters अगर इसका आंसर होगा, अगर इतना सा wavelength होगा, negligible, non-seeable होगा, तो वो वेव नेचर कैसे दिखा पाएगा? Will it be able to show? See, जितना ज्यादा वेवलेंथ लंबा, जितना वेवलेंथ ज्यादा या जितना बड़ा वेवलेंथ, उतना आप उसके वो लाइट का या वो पार्टिकल का वेव नेचर देख सकते हो. ठीक है, बट हियर द अर्थ इज शोइंग सच अ स्मॉल और मिनिस्क्यूल वेवलेंथ. इतना अगर छोटा वेवलेंथ दिखाएगा तो ऑब्वियसली देयर इज गोइंग टू बी नो विजिबल प्रूफ ऑफ अर्थ बीइंग अ वेव नेचर एज वेल. अर्थ बीइंग पार्टिकल नेचर ये तो दिखता ही है. अर्थ का मटेरियल को आप हाथ लगाओ, बॉडी को हाथ लगाओ तो समझ में आता है. बट अर्थ को आप वेव नेचर में देखना चाहते हो तो उसका वेवलेंथ बड़ा होना चाहिए, बट उसका वेवलेंथ ऑलरेडी इतना छोटा है, तो नॉट एट ऑल सीएबल. क्लियर हो जाए.
695 into 10 to the power minus 63 meters. Can you tell? The expression T is equals to E by C defines the momentum of a photon. Can this expression be used for the momentum of electron or proton? Answer. The definition of momentum of photon given by the de Broglie hypothesis is applicable only to those particles whose rest mass is zero and travel with the speed of light.
Again, ये जो मोमेंटम होना चाहिए था, वो मोमेंटम बहुत हाई होना चाहिए, या फिर उसका स्पीड जो है बहुत
As the electron and photon have finite rest mass and their speed is not equal to speed of light, this expression of momentum P is equals to E by C cannot be
cannot be.
used for electron and proton. Davisser and Germer experiment.
This has been
A symmetric
deleted.
Use your brain power.
उससे रिलेटेड डिलीटेड उसका
wave
एग्जाम.
particle duality of matter.
Okay, wave particle duality of matter. So this is the last point and this is what I was talking about. ये जो है मैटर का डुअलिटी, मैटर का पार्टिकल डुअलिटी हमको पता है, ठीक है. मैटर का पार्टिकल नेचर हमको पता है, बट मैटर का वेव नेचर नहीं पता है. और ये अपने डिब्रॉय ने प्रपोज किया था कि मैटर का भी वेव नेचर है. मैटर भी वेव नेचर में घूमता फिरता है, मूव करता है, ठीक है. दिस इज व्हाट ही हैड ऑलरेडी सेड.
Material particle shows wave-like nature under certain circumstances.
देखो
This phenomenon is known as wave particle duality of matter. Frequency omega and wave number k are used to describe wave in classical theories, while mass m and momentum p are used to describe particle.
right?
Wave particle duality implies that all the moving particles have an associated frequency and an associated wave number, and all waves have an associated energy and an associated momentum.
So this word associated is very important. See, it is not directly given to the body or that matter. All this wave number, this frequency, this wavelength has been associated with that given
We
matter.
come across the wave particle duality of matter due to quantum behavior when we are dealing with microscopic objects where size is smaller than equal to 10 to the power minus 6 meter.
See, so if we come across the wave particle duality of matter due to quantum behavior, we are dealing with microscopic objects.
Smaller order of magnitude of h sets the scale at which quantum phenomena manifest themselves. If all the material objects in motion have an associated wavelength and therefore an associated wave, why then we do not talk about wavelength of a child running with a speed v on a pathway 2 meter wide or a car moving with a speed v on a road 20 meter wide.
तो हम किसी बंदे का, किसी कार का, is time travel possible? Cause साइंटिस्ट ने कहा था कि टाइम ट्रैवल तभी पॉसिबल होगा जब ऐसा मशीन बना दी जो लाइट से भी स्पीड हो, और कोई लाइट की स्पीड से कैसे जा सकता है. So it can even shrink. Yeah, it is possible if we have some machine which will help us to travel more than speed of light. Or again the Goku Vegeta thing, if you are a Goku or a Vegeta, you can absolutely time travel and go ahead in time or go back in time. Okay, and it will obviously have its effect on the body as well. The body might shrink, the body might go very small, the body might become very big. You must have seen in Avengers Endgame as well, that Ant-Man guy बहुत छोटा होता है, इसीलिए वो पहुंच पाता है. टाइम ट्रैवल वगैरह होना पॉसिबल होता है, फिर वो बड़े लोग के लिए बनाते हैं. दैट हैज बीन शोन, मीन इट इज अ मूवी, सो दैट हैज बीन शोन. बट अभी तक तो ऐसा बोलते हैं बनाने. वी रियली डोंट नो व्हाट एग्जैक्टली है भी या नहीं भी. ओके,
To understand this, let us try to calculate these
तो अभी
quantities.
हम एक बच्चे का
The
wavelength निकाल
wavelength
के देखते हैं.
calculated in example are negligible compared to the size of the moving object as well as the width of the path on
देखो ना, वेवलेंथ 10⁻38 मीटर है. 10⁻38 मीटर मतलब कितना छोटा वेवलेंथ है. अरे इतना छोटा वेवलेंथ होगा तो वो वेव फॉर्म में कैसे ट्रैवल करेगा. ठीक है, द वेवलेंथ्स कैलकुलेटेड इन द एग्जांपल आर नेग्लिजिबल कंपेयर्ड टू द साइज ऑफ मूविंग ऑब्जेक्ट एज वेल एज द विड्थ ऑफ द पाथ ऑन विच द ऑब्जेक्ट्स आर मूविंग. ओके, मतलब अपनी कार जो दौड़ रही है या फिर अपना जो बच्चा दौड़ रहा है वो रोड पे, उसका वेवलेंथ बहुत ही कम है. उसका वेवलेंथ बहुत ही कम है और इस वजह से उसका जो वेव नेचर है वो हमको विजिबल ही नहीं होता है.
which the objects are moving. Therefore, the wavelength associated with the macroscopic particle do not play any significant role in our everyday life and we need not consider their wave nature.
ठीक है, इस वजह
Also,
से
the
हम उसको wave
wavelength
nature
for
में consider नहीं
macroscopic
करते.
particles are so small that they cannot be measured. On the other hand, if we try to estimate the associated de Broglie wavelength of a moving electron passing through a small aperture of size 10 to the power minus 10 meter or an oxygen molecule in air, we will find it to be significant and can also be seen in the following example. The wavelength of the electron in above example is comparable to the size of the hole through which the electron is passing.
ठीक
The
है, अभी ये
wavelength
इलेक्ट्रॉन का वेवलेंथ देखो 10⁻⁻10 मीटर, ठीक है, 1.23 एंगस्ट्रॉम यूनिट्स. ओके, तो अगर ये एंगस्ट्रॉम यूनिट्स में दिखा रहा है इतना, सी दिस इज फेयरली इनफ फॉर good. Your brother believes in something which is unbelievable, and that makes things possible. ठीक है, so that's good. Your brother, he might even invent a time traveling machine. I hope he does, and we go back to our childhood. Okay, coming back to this chapter, this last point, कि हमने जो ऑब्जेक्ट मूव कर रहे थे रोड पर, वो कार हो गई या फिर वो बच्चा हो गया, तो उसका जो वेवलेंथ हमको मिला, दैट वेवलेंथ वाज वेरी शॉर्ट, सॉरी वेरी 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 शॉर्ट, वेरी शॉर्ट नहीं, वेरी 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 शॉर्ट, 10⁻⁻38 meters. And this electron that is moving is having a wavelength of 10⁻⁻10, which is fairly acceptable, and thus you can see the
wavelength associated with this
wave nature
electron
of
is
these
same as
electrons.
the size of a helium atom and more than double the size of a hydrogen atom. Photon picture allows transfer of energy and momentum in the same manner as in Newtonian mechanics. Wave nature does not modify that. Wherever wavelengths are small compared to the dimension of the slits or obstacles or are not measurable, we can use Newtonian mechanics. In conclusion, for both electromagnetic radiation and atomic and subatomic particle nature is dominant during their interaction with matter. On the other hand, while traveling through space, particular when their confinement is of the same order of magnitude as their associated wavelength, the wave nature is
dominant. Okay, so the basic thing that we need to understand, the basic point that we have to write in this question about wave particle duality of matter is that whenever the particle or whenever the matter is interacting with the particles, whenever the matter is interacting with these particles, so we consider this as a particle nature, we consider this as a particle nature. But on the other hand, whenever we talk about momentum, that is whenever we talk about velocity, speed, ये सारी चीजों की जब हम बातें करते हैं, तो जो मैटर है इट गेट्स एसोसिएटेड विद द वेव नेचर. ओके, तो ये डुअलिटी हमको दिखती है. सेम हमने लाइट के बारे में पढ़ा, सेम हमारे मैटर के साथ भी होता है, बट मैटर में आपका वेव नेचर बहुत कम दिखता है और आपका लाइट में पार्टिकल नेचर बहुत कम दिखता है. सो दीज आर द टू कॉन्ट्राडिक्शंस, बट या in both the cases particle and wave nature are absolutely present, and they have been proven. It's just one of the other is dominant in certain situations or certain cases. That's it. Okay, so this was the chapter all about. Done. So very easy, simple, straightforward chapter जिसका आपको ज्यादा कुछ करना नहीं है. ठीक है, there are few questions, very few questions which are actually expected to be in the exam, like wave particle duality of matter, wave particle duality of electromagnetic radiations, or at the max what they can ask is photoelectric effect. ये 3 questions छोड़ के Einstein's postulates, experimental observations, ये सारी चीजें वो नहीं पूछेंगे. They are not going to ask. Or they might ask, combination करके 14.2 हो गया, then I guess 14.3 and 14.7, इन तीनों का कुछ कॉम्बिनेशन करके पूछ सकते हैं. उससे ज्यादा वो आपको पूछने नहीं वाले हैं. ओके, सो इतना ही आप पढ़िए. डोंट गिव एक्सेस इंपॉर्टेंस एंड एक्सेस ऑफ टाइम टू दिस चैप्टर, क्योंकि कोई पॉइंट नहीं. इससे इंपॉर्टेंट और इससे बड़े बड़े चैप्टर्स ऑलरेडी है. ओके, तो आप उस पर फोकस करिएगा. इसको आप पीछे भी रख सकते हो, इसको मैग्नेटिक मटेरियल्स को, इन 2-3 चैप्टर्स को आप यू कैन कीप देम असाइड जस्ट फॉर द रीजन, चलो पढ़ लिया तो पढ़ लिया, नहीं पढ़ा तो भी इतना कोई फर्क नहीं पड़ेगा. बट क्या है ना, बीइंग इनटू योर सिलेबस उनमें से क्वेश्चन आएगा, और ये इतने इजी वाले चैप्टर्स हैं कि शायद इनको पढ़ना भी आपको बेनिफिशियल रहेगा. समझो कोई पहले वाले प्रीवियस चैप्टर्स में से डिफिकल्ट क्वेश्चन आता है और उसके अपोजिट में इसका कोई इजी क्वेश्चन आता है, इसमें से इजी आना है बेसिकली, तो आपका लक चल सकता है एंड यू नो इट माइट बी in your favor, it might be in your favor that this question has popped up from this chapter. Okay, so this was it about the 14th chapter. Okay, this was it about the 14th chapter. Next week I don't know how the setup will be, but next week we will be meeting with the second last chapter, and we'll be, you know, maybe in 2 weeks we'll be completing all the entire portion for 12th standard. Okay, and keep studying, keep working hard, and enjoy the lectures on YouTube as well as on the Home Revise app. Thank you very much for being there. Take care.